Okay, so my name is Jim Falgu. I'm the Chief Technologist of the Big Data Analytics Group at Actian Corporation, formerly Pervasive. We just went through the acquisition page, what was it, like 3 weeks ago? So if I say Pervasive, I really mean Actian. We just went through it, so it's still a little new to us. So let's start off there. So what is Actian? So they're calling it the new Actian because really Pervasive was just about as big as Actian was. So it's really more of a merger than an acquisition. So they have tens of thousands of people, users worldwide, lots of people skilled in the really focused on data. One of our other acquisitions was VectorWise, which is a very, very fast analytic database. We also just bought ParaXL, which is a huge scaled-out database, analytic database also. That happened last week, I believe. So they're growing very, very fast and really focused on data. And their catchphrase is taking action on big data, and that's what it's really all about, right? So it's not just about the data and how interesting it is and what can we do with it. It's what kind of actions can we take with it? What kind of knowledge can we find in that data that's really going to help us make better decisions? That's going to help drive our company. And you look at the companies that are really focused right now, that are really successful, and if you look a little deeper, you'll see they're the very data-focused companies who are using data not just to look back, but also using data to predict where they should go. All right, so I want to talk a little bit about what our CTO, Mike Hoskins, pretty popular guy here in Austin. If you know him, he's he likes to kind of put things out there, right? Like he likes to sort of throw a few bombs and kind of see what hits. So he has this new thing he's talking about called the age of data. So I'll go over a couple of slides of that. Just to see what you guys think about it, and we can talk about it. So the format here was we do about 45 minutes of presentation. I don't think I'll have 45 minutes, but we'll see. And then like 30 minutes of questions. So let's take that time to have a conversation. And if you have any questions for me, I'd be happy to answer them at that point. Talk a little bit about the scaling gap, and this is where kind of the technology comes into play. Because when you're talking about big data, of course, how do you do that? You need the technology, you need the infrastructure, you need to be able to scale out. And just talk about kind of where we're at today. And I want to kind of bring in the human side of this a little bit. And this is where I'm talking about data scientist. So who's heard of that term, data scientist? Okay, just about everybody. I kind of want to touch on that a little bit because I think it really helps look at how this came about and sort of where it's going, and that could give us a sense of where the technology should go. Okay, and we gave a nice kind of marketing spin to the talk, talking about who buys what with bananas. So we're going to kind of peel that banana back a little bit, walk through a use case of using our technology, doing market basket analysis, and really just want to kind of give you a flavor of sort of a data project. When you get a large set of data in, how do you start tackling it? What are the things that you start looking at? And what are some of the things that you can get out of it? And I was talking to Melanie earlier. She's in our marketing group also, and her first question when I walked in was, so who buys what with bananas? What's the answer? And I was like, well, we can talk about it a little bit, but this is actually based on customer experience and being a vendor, not like owning the data. There's only so much I can talk about it. So we can give some answers, I can give some clues, but not going to go real in depth into the actual data itself. Okay, so that's what the talk is going to look like. So right now he says entering the age of data. I'd say we've already entered the age of data. This started with kind of a digital revolution. You look at more of the age of hardware, starting with kind of World War II on, age of software. When did this end? It didn't really end, right? We're still going to always be developing software. But where is our real value today? And it's in data. You look at the internet age, the internet scale of things that's happening today. And it's really all about the data and what we do with it. So what's really changed? Data has become really a central business asset. I've heard people say data is the new oil, right? It's the new thing that really helps businesses drive where they're going, what they're doing, how they make profits. It's a non-depletable kind of asset. And one thing Mike likes to say, and I think this is a great analogy in this area, so think about, let's say you have all this data in a database, and you want to go to a new database system. Do you throw your data away? No, of course not. You migrate your data, and you hold on to that data, right, because it's really valuable. You might use it with new software, but the data stays, and that data stays around forever. You're going to hold on to it. It has value. But one thing that's really changed over the last few years is the data generation has changed. And what we mean by this is everything's instrumented. Your phone's instrumented. Every sensor we have is instrumented. Every piece of equipment we have is instrumented. We're constantly collecting these timestamp type of events, these digital events, and we're wanting to get information from them. So this is a real big change from what used to be kind of master data that we would keep around, things like customers, maybe inventories, stuff that wasn't really all that big. This digital data, these timestamped events are enormous, and they're just getting bigger. The volume's getting greater. The velocity is getting greater. The amount of data we have to store is just getting greater. And Mike, being a philosopher, likes to talk about all things are flowing. This is a quote from 500 BC. So even back 2,500 years ago, big data was actually a really hot topic. So, all right, maybe not. So what are some of the hallmarks of the age of data? Data ubiquity. And for this, we use this just as an example of looking at APIs, web APIs, right? Just as a measure of how much data is out there, how much data services are out there that people are building, and just look over the course of, this is from like 2008, 2009, the massive growth in this area. So what kind of problem does that mean? It's a data integration problem, right? So I need to get my data out of those services, or maybe get them into those services, maybe collaborate with different services, kind of bring that data together in different ways. There's been a huge explosion of intelligent devices, 25 billion by 2020, which means there's more devices than people in the world. That's kind of crazy. And all of those devices are constantly tracking, they're constantly collecting data. There's information about that can be used to help you, maybe kind of big brother-ish type stuff, but still, it's a lot of information. So what does that mean? Huge data analysis challenge. And we talked about this a little bit, the primacy of data events. And so this is kind of the shift of the last few years from master data, organizations, people, machines, CRM type data, into timestamped digital data events that they emit. And they emit those constantly. So there our focus now turns to identifying those key event generators and building event processing pipelines to handle them. And this is a huge challenge. All the value comes from the ability, though, to quickly and very economically, and I think those are two really key words there, economically, and of course quickly, analyze and act on those events at scale. I think a really good example of this is Dell started this several years ago on their website. Well, they will make an offer, and they will actually, in real time, see how that offer works. If it doesn't work, they'll change it. And they'll change it like by the minute. And if that new offer doesn't work, they'll change that. They're constantly, that constant feedback loop of trying something, it didn't work, or it worked, let's try it, let's kind of change it, let's react. That very quick reaction to that. Being able to do that means you have to move at scale. I want to give a few kind of examples of that have seen more in the public eye that have been done with data. And this was a quote from this guy from Personal Democracy Forum, where he said, in the 21st century, the candidate with the best data merged with the best messages dictated by that data wins. And he was specifically talking about Obama's campaign, where they used social media, they used data warehousing, they used Hadoop, they used all these technologies and brought them together. And they would do things like, well, let's go out and kind of poll an area and figure out what kind of people are in this area and what they react to. They would send out mailings, they would send out email campaigns, they would look at Facebook, they would really get interested in what, not just people in general we're talking about, but even individual people. And then try to make some sort of, what's the word? Like presentation to them of their, issues that they thought were important to them and see how they react. And if they reacted well, then they knew that was successful. And they went into this whole trial and error, let's try it. We have the data. We can actually then, really pinpoint things very quickly. So he talks about using Hadoop to aggregate generations of data and then being able to put that into a real-time analytical type database and then just do queries on it. And that's really important. I think it's an important point, and we'll talk about that a little bit when we talk about data scientists, because giving people the room, giving people the freedom, the creativity to kind of take data and run with it is really important. And that's a huge part of what's kind of different about the way we do things today. This one was kind of interesting. This actually was a project that a couple of academics took on, maybe not great science here in the sense of impact on the results, but they actually took from Google, who digitized all the books of the 20th century. Now, I remember at some point when we were talking about the Internet of Things, way back when in the 80s, early 90s, and someone said, well, if we could take all the books in the, Library of Congress, it would be, X number of bytes. And I just remember thinking, that's incredible. We'll never be able to store that, because back then, a 250 megabyte hard drive was a big deal. Well, now they took all the books of the 20th century and made them, not only put them, digitize them and they have them available, they made it publicly available. Anybody can access it through their web services. So they took this data, they enriched it with mood scores from WordNet, and they counted the occurrences of mood words. So really just trying to see what was the mood of books, of writing, of literature at the time, and how has it changed over time. Okay, so why do I think this is interesting? Well, Google, who else could take all of that data and make it available publicly and make it available for all this analysis? But, and I think the point is, that kind of data is out there. And this is just one public data set. There are hundreds of them. Go look on Amazon. They have a public data set area where you can download all sorts of information. The information is out there. You can bring it together in really interesting ways. So this is called repurposing, right? This is where I'm taking data that someone puts out there. They don't really maybe know what people are going to do with it. They just make it available, and it's up to you to decide what to do with it. Okay, 2 examples. Just wanted to kind of seed the thoughts a little bit with that. All right, the scaling gap. So what we mean by that is, in the age of data, if you're not super scaling, you can be failing. So what does super scaling entail? This means using off-the-shelf hardware, right? So it's got to be cheap. It's got to be easy to build. It's got to be easy to put together. And building that with software stacks that can consume, that can analyze, that can act on this data. And it must be really frictionless. And there, we mean it shouldn't take me a month to get this set up and ready to go. If you use something like Amazon, you can get it up and running in an hour. I can go to Amazon and start up a cluster, a 20-node, 30-node, 40-node cluster within minutes if I know what I'm doing. And so that capability is out there. It's just up to you to take advantage of it. But it has to be very performant, so it has to scale up. And by that we mean if you have a single machine, can I take advantage of all the resources on that machine? It also has to be able to scale out. Can I take multiple machines in a cluster and really utilize those resources? And scale out is extremely important, especially when you talk about internet scale size data. Has to be elastic, and this is where things like Amazon come in, right? Can I run something on a really large cluster when I have a lot of work to do, and then scale that back to something that I might need more on a daily basis, and still be affordable. So the hard truth, really, a lot of legacy software isn't really built to superscale. A lot of it's not even really built to scale, and there is no path to reasonably, and by there we mean economically, get there. So yeah, there are a lot of analytic databases out there that are very, very expensive and very expensive to scale. So what does that mean? So your legacy analytic software will fail in the age of data, may fail, depends on what you're doing. It's kind of a broad statement. But the idea there is that we have to change the way we're doing things. Okay, so that sort of sets the scene for the age of data and kind of what we mean by that and kind of where we're at today. So again, I kind of want to start on sort of the human side of this equation also. And here we talk about data scientists, and Paige is laughing at me because she sees my Iron Man 3 icon up there. If you haven't seen the movie, it's awesome. Well, it's a blend of the superhuman and the human, right? Okay, yeah, you're right, human side. And so where did data science kind of come about? Well, this was think back to the early days of LinkedIn and Facebook and a lot of these kind of internet scale companies, and they had a lot of information. They tried to do what everybody was doing at the time. They had Oracle, or they had MySQL, or they had these types of databases, and they tried to make them scale to work with this size data, and they just ran out of horsepower, and they ran out of money. So what did they do? Well, they invented things like Hadoop. They invented things like Facebook invented Hive. They invented all sorts of tools to work with this data. So these are people who have kind of a mixture of math skills and computer science skills and sort of the perseverance of hacking type skills and made all this happen. One of my favorite stories about kind of a data scientist, so at LinkedIn, if you don't use LinkedIn, so LinkedIn's sort of like the Facebook, but for professionals, right? So you can kind of link together and keep up with what's going on. One of the engineers at LinkedIn I think he went to Cornell, and he was really interested in who might I know who went to Cornell who's on LinkedIn. So he started playing around with it. He's one of the data scientists. He kind of had this room to sort of play a little bit. And so he started taking their data, he dumped it on Hadoop, and he did this link analysis. And he found some people that he went to Cornell with that he didn't know were actually in his area. They lived in California, near where he lived. So he connected with them. He thought that was really cool. So he told his boss about it. And his boss said, that's really cool. So let's see what we can do about it. Let's see if we can make this bigger. And they took his experiment, and next thing you know, within a month, it was one of the biggest features on LinkedIn. So this is what I talk about when I talk about these kind of giving people the time to explore, giving people the place to explore, and giving them the tools and the data to explore with what can come out of it. Because who you know or who you may know on LinkedIn is one of their biggest features. All right, I read this really interesting blog the other day. Is statistics dead? And this was written by a PhD in statistics. And so he's feeling a little bit left out because he's not a data scientist. And he started asking the question, well, what is a data scientist? Don't you need statistics? Of course you need statistics. Statistics isn't dead. Statistics is all about the analysis of data. But the focus in the last few years over formal statistics has really narrowed. It's been more of a kind of a healthcare, pharmaceutical, experimental type of statistics, smallish type data, desktop type tools like R. Data scientists really evolved that due to the impact of internet scale data, right? So they need to invent new tooling to handle their data volume, their data velocity, Hadoop, for example. And they also needed to work on a much wider variety of data. And when I say variety, I don't mean like data that has lots of different attributes or different types of attributes. Of course it has that, but by that I mean it's not the normal kind of statistical data that statistics field in general had become focused on. They had lots of new questions they wanted to ask. They had lots of different ways that they had to handle that data. Things like unstructured learning, machine learning types of algorithms that they wanted to be able to run. So this required really a mixture of skills. And it's really interesting because universities are responding to this. There are a lot of online courses now on data science, kind of starting data science. What does that mean? And how do you now get statistics to quit being such a narrow focus to be a much broader focus? You really should have statistics professors in your computer science courses. You should have that in your data science courses that are starting to come about. And that's happening. And it's really interesting to kind of see how universities are evolving to respond to this. All right, I love this because being a nerd, if you're going to be a nerd, you may as well be an awesome nerd, is what I say. So now I know what it means to be an awesome nerd. Okay, this was from Vincent Granville. He's very active on datasciencecentral.com. And he just kind of put this together just saying, okay, what are these data scientists, right? They're these awesome nerds that combine computer science and engineering, math and statistics and hacking. And here we mean like the good hacking, not the black hat kind of hacking. By hacking, I think he really means people who are just persevere, right? If you give them a problem, they're going to hack at it until they figure out how to make this work, how to get what you want out of it. Physicists are great data scientists because they're used to just squeezing every ounce out of data that they have, every ounce of information out of the data that they have. And they just have this kind of innate ability to see the big picture and kind of figure that out. I don't have a physics background, but I've worked with a lot of physicists who have kind of moved into computer science. And they just have sort of a different way of approaching things than kind of the engineering type of mindset. This is more of a Venn diagram of data scientists. This is from Drew Conway. And the thing that I thought was interesting about this, of course, hacking skills, you see sort of the same things, math and science skills. And he calls it substantive expertise. And by there, he really means relevant experience with data, tools, open source data, open source software, data techniques, just all those skills that you kind of build up over time. But I really like where he talks about, if you have hacking skills and you have that expertise with data, but you don't have that math and science background, you can really build some stuff that's not statistically valid. and could be lacking some interpretation, right? So yeah, sure, I can go do a linear regression over some data. I can get the coefficients. So what do I do now, right? How do I interpret that? How do I know, is it valid? How do I know if I built the right model with the data that I have? And then how do I apply that model, right? So you really need kind of that blend of all those skills. And he calls that the danger zone. And I've kind of been in that danger zone before, where you have some data, you look at it, you make some assumptions from it, and you bring that to someone with more of a statistics background, and they start asking all the hard questions about experiments and how did you validate this, and did you do a training data set and a validation data set? And you're kind of like, yeah, but look at these results. This is awesome. They may be awesome, but they may also be wrong, so you have to be careful with it. All right, so 2 quotes in this, and I really wanted to focus on the parts that I highlighted. So the bolding is mine. But I like the first quote where Hillary talks about appreciating data itself as a first-class product. And this kind of goes back to what we were talking about before with the age of data, right? So data really is a first-class product. And look at infochimps.com here in town. Data is really what they do. They provide you, they take all these different data sources, they bring them together, and they provide it to you in a way that you can consume. Data is their first-class product. And the last one, I explain it to the business leaders. That's really important, right? So this isn't, it's not data science for data science sake. It's data science to do something about it. So once we make these discoveries, right, then we have to be able to communicate that in a way to business leaders and to business people so that they can do something with it. They can do something valuable with it. And that may seem like really obvious, but to kind of engineering types, that isn't always really, really obvious, right? So something we have to work on. Okay, so what is the process that we see in data science? And you could apply this to just data mining, which has been around forever also. And you see on the prepare stage, there's a lot more words there than on model and communicate. And that's because everyone I talk to, go to all these Hadoop conferences, we go to predictive analytic world type conferences, and you talk to people about their data mining projects, their data science type projects, and they always say the preparation stage is 80 to 90% of the amount of time that I spend on a data project. So that's huge. And so that tells us as a vendor, we need to spend a lot of time in that area to provide that capability. All right, modeling. So what is modeling? This is where I'm now going to take my data. I'm going to build some sort of model on it that's going to help me either understand what's happening or take that knowledge and be able to predict in the future what we think is going to happen. And the thing about modeling, like one of my favorite quotes about modeling, and I can't remember who said it, but it was something to the effect of, all models are wrong, but some are really useful. And that's true, right? So these are mathematical models, so they're not always going to be perfect, but hopefully better than random. And that way, then they're useful, and we can use them to help make good decisions. So modeling, what do? We experiment, we explore, we hypothesize, we build a model, it's wrong, we go back, we do it again, we iterate, and finally we validate and make sure that it works with the data we have, and then we deploy it. And part of that deployment is communication, right? So this is where we're going to visualize. We're going to take some data, we're going to run it through that model, we're going to show what the results look like, we report it, we explain it, and most importantly, we put it into action, right? So that's where Actian, action, putting data into action, that's kind of where we focus. All right, some of the tools that are available in the big data context, and this is by no means a comprehensive study, right? I just want to throw some out there, and probably some ones that you've heard of. Hadoop, of course. Mesos, which is actually a very Hadoop-like kind of framework that Apache also sponsors. And these are both Apache projects. Apache, if you don't know, is a big open source kind of clearinghouse of open source projects. We use them all day, every day. They have some really awesome projects there, Hadoop being one of those. And we'll talk in a minute about Hadoop and a little bit more detail on it if you're not familiar with it. I throw DataRush out there. This is an Actian product that I work on. I would also throw HPCC, which is from, Paige, help me out. Who makes HPC? Is this Lexis next? No. I can't remember the name of it. It's gotta be, sorry, I kind of blanked. It's a very Hadoop-like, they've open sourced it. It used to be their internal kind of data processing framework, and they decided to open source it also. Very similar to Hadoop. Analytic databases, of course, like we talked about earlier when we saw some of the data examples in the Obama campaign where they used, Vertica was one of the databases that they used. In that arena, we have Astrodata, Greenplum, Netezza, Parexel, which is not part of Actian, Vectorwise also, Vertica. In the open source arena, we have Cassandra, HBase, MongoDB, and there are several others. The analytic platforms, things like Tableau, of course, all the BI space players there, Rush Analytics, which we'll talk about in a minute, SAS, SPSS. Here I was thinking, I guess, more data mining when I said analytic. All right, so Hadoop. Sorry, let's do another survey. How many people know about Hadoop, have used Hadoop, familiar with it? Okay, great, quite a few. So Hadoop is open source. It's a very much a distributed or scale-out platform for data processing. And the key here is on cheap, I say cheap hardware, I mean, like over-the-counter type of hardware. This is not something you have to go special order. We have a 5-node Hadoop cluster at Actian in our lab, and it cost us around $75,000 to put together. And that was the 5 worker nodes, it was 2 head nodes, it was the network switch, and the rack. So it was kind of, soup to nuts, about $75K. Now, I worked for a supercomputer company back in the 80s and 90s. Give my age away a little bit there. But in Dallas, Convex Computer. And one of our computers that would have had that type of power would have been millions of dollars, right? Tens of millions of dollars. So part of what we were talking about before about this being ubiquitous, right? With this cheap of hardware and with this open source type software, sprinkle in some of the stuff that we do, that others do, bring all this together, you have a really powerful platform for handling just an enormous amount of data and doing just really awesome things with it. So some of the components of Hadoop are HDFS, which is their distributed file system. MapReduce, which is more of the computation framework. So the idea there is you have 2 phases that you do with your data. You map it, and this is where you take some input, you produce a name-value mapping, you maybe munge the data in some way, you transform it in some way, and then you go into this reduce phase, and that's where you apply a final reduction on the data itself. So a lot of, MapReduce is okay. It was great for indexing the World Wide Web, which is really what it's built for. It's not great for doing deeper data analysis, and we'll talk about that in a minute. HBase, this is a name value data store. Again, very distributed. You can just put an enormous amount of data within it also. Uzi, Zookeeper, these are kind of more of the management kind of pieces around it. Hadoop is large. It's a really large ecosystem that has been built up over the last few years. There are several distributions of it, so you can get it directly from Apache. Again, it's an Apache project, so it's open source. Cloudera and Hortonworks, MapR, Intel, they all have their own distributions, so you can actually go to them. Most of them are not open source, but they are free to download. And if you want like an enterprise level, or if you want some of the other sort of enterprise pieces they built on top of it, then you would pay for it. You pay for support, you pay for consulting and things like that. So that's kind of how they monetize it. Okay, so we're going to jump right into this use case study. And with this one, in particular, we're doing market basket analysis. So this is where you're going to take data from a retailer. They have some sort of point of sales data. And this can be an online retailer. This can be a brick and mortar retailer. This can be a mix of the two. The analysis is pretty much the same. So we're looking at items that are purchased in the same basket. And those are captured and usually called line items. We take a summary of each of those baskets, and that's usually the basket itself or the order. Depending, if it's online, they tend to call it orders. And then information about the items themselves, the UPC, the SKU, whatever they particularly call it. Some sort of description, like usually some sort of category hierarchy. So if I buy bananas, that's going to be in grocery, or maybe even produce, and then grocery, and on up the hierarchy. So the type of analysis that we do, and this is by no means comprehensive because we could spend all day just talking about market basket analysis and then the sort of things that you can do. But in general, what do retailers want to know? Well, they want to know what items sell well together. They want to know what items drive the purchase of other items, because just because 2 things sell well together, it's hard to figure out what's the correlation in there. Is there a causal a relationship versus just a correlation? That's really interesting because if one causes the other, now that kind of changes the equation a little bit because it affects how I do product placement, it affects how I do promotions and couponing and things like that to drive people. Because if I know you're going to buy this item, if you buy this other item, then I don't really have to promote the other one, right? I promote the driver item, and I know it's going to lift stuff into the basket, so to speak. All right, understanding customers and buying patterns, not always easy in things like grocery stores because you don't always know who they are. And then, and that's why they like loyalty cards, right? So if you use a loyalty card, that's part of why grocery stores like that, because then even if they don't know maybe exactly who you are, they can identify your purchase, and they know this is made by a specific person, and they can kind of see what sort of things you like to buy and monitor your buying patterns. And of course, also measure promotion performance, loyalty card, how is that performing, things like that. All right, so this type of analysis that we like to do on this type of data. All right, so we were given hundreds of millions of rows of point of sale data from a particular vendor. We have this, this is actually our development cluster we have in our lab. It's 3 nodes with a head node. It runs Cloudera's CDH4, their release, and we used our own DataRush product with it, version 6.1. All right, so analysis tools that we use running on the desktop. We use our Rush Analytics tool and Gephi, or Gephi. I can never really figure out the right way to say that. This is an open source graph visualization tool. It is awesome. If you've never used it before, if you have graph type data, it's really easy to use, and it's really kind of fun to play around with it. And you can see all sorts of interesting patterns doing that. All right, so what's Rush Analytics for KNIME? This is one of our products I'll be talking about. KNIME is actually an open source. You keep hearing me say open source, right? So we depend a lot on open source to do the things that we do, because those data scientist people that we're targeting, they use open source. So we have to really kind of plug into that very, kind of as seamlessly as possible. So this is an open source platform, analytics workflow platform. It's highly extensible. It has a very active community of contributors. It's really popular in Europe. It's not so much here. The company that builds it is based out of Zurich. And so we've done a lot of work with them. We really like it just because it's based on Eclipse. If you're familiar with Eclipse, Eclipse is a very extensible desktop type platform. It's commercially available also. They have a server, team space, report products that are available. So it really, it has a very collaborative type of feel to it. So you can have, multiple people working on analytic type projects. So we built this product we call Rush Analytics. This is developed by us to extend KNIME, really because we're horrible GUI programmers. And we're more of kind of back-end server, analytics type group. And we saw this really beautiful UI and thought, let's just take advantage of that. And that's what we did. So it's taking our DataRush technology, it's kind of shoving that into KNIME, so to speak. And it also allows us to kind of wrap a lot of our functionality in this really nice GUI very easily. And that's kind of the marketing spiel of what I just said. Taking all that, again, that whole access your data, collect, prepare, analyze, and visualize. Nice thing about Eclipse, that KNIME also, it's almost a portal in the sense of, all these other people have contributed plugins to it. And so you take our plugin, you take their plugin, you mix and match, and you kind of get what you want out of it. So it's a pretty nice environment. All right, so let me show you kind of what that looks like real quick. So very nice GUI-based product. It's a desktop-type product, but I can still, with Rush Analytics installed, I can actually build out workflows and run them on my Hadoop cluster. So I can still do very large data analysis with it without having to write a line of code. So the idea is you have all your workflows. It's just kind of a way of managing your work. Then you have all of these nodes, they call them, which are just a functionality that you can apply. So the idea is that you just drag them onto the canvas, you link them together, you set some properties, and now you can just run these workflows. You can save them so that you can share them with other people. You can monitor them while they're running. Again, a very nice drag and drop, very easy to use. I mean, we've introduced this to people. This one engineer that we were working with Esri recently, and he wants to put a lot of the Esri functionality within this framework. And within 2 weeks, he had built 5, 6, 7 nodes within the framework, integrating our software with KNIME and his software all together. So it's very easy to use, very, very easy to extend, which is what we like about it. It can really produce anything you want it to do. We can process your data and dump it back into Hadoop. We can dump it into a local file. If you're doing some sort of data analysis, we may end up building a model in what's called PMML, which is the predictive model markup language, which is XML based. It really depends on what you're trying to do. And it's a very open, very flexible framework. So you can pull data from any source, you can do whatever munging you want to do on it, and then output it in just about any format. Okay, so we have this retail data, and now I have to start with it. So if we go back to our steps as a data scientist, what am I going to do? Well, I have to kind of prepare the data. I have to do that cleanup, that discovery, that I just got handed this data. I don't know what's in it. And you ask the people who hand you the data, so here are all these transactions, and they're like, oh yeah, data's complete, it's clean, it's great, and they're never right? People always give you data, they don't realize just, maybe sometimes how dirty it is. So first thing I always do, for example, I just took the data, I did some I used our data summarizer node, so I can kind of look at the data and see what it looks like. And immediately I came up and saw that the quantity, which is, the number of items that you bought in a basket, the minimum value is negative something. Well, why is the negative value in my quantity? I don't understand that. So the first thing I thought is it's probably returns. So we have to go back to the customer and say, does negative quantity mean return? They go, oh yeah, forgot to tell you about that. Okay. So we got that one. And then also notice there's some missing values, right? So that means we have to handle those. Well, in this case, I'm just going to throw those out. I don't want to have to deal with them. And in fact, we went back and looked at it and saw that for all the returns, that's where we're getting the missing values. So if we just get rid of the returns, then we're okay. So that's kind of part of that discovery phase, right? But this is a lot of data. This is 400 million rows of data. So I'm not, I don't want to just load it into a database and then start looking at it. I kind of want to play with it first before I got to that point. And this tool kind of allows me to do that. All right, so now I want to cleanse it, I want to enrich it, I want to aggregate it, and what I'm going to do here is I want to filter out those all those baskets with zero quantities. So I just bring up this node, my filter node, and then it allows me to say, if my item count is greater than 0, then I'm going to keep that data. The rest I just want to throw away. I'm not going to worry about. Okay, so and then what I want to do here is I wanted to create a unique transaction ID for each item set, for each line item, and then for each order. And so what I'm going to do, or each basket. So I had to take like the transaction date, the store ID, the register ID, the transaction number of that register, and then put all that together, and that gives me a unique key. So not a lot of science here, right? We're just having to kind of get the data into a state to where we can actually then do something with it. All right, I want to select fields. I want to get rid of all this kind of data that I don't need anymore. And then I'm just going to take that data, actually then doing some aggregations, because one thing we found too was we were having duplicate line items in our orders, which again the customer didn't even know about. So then we have to analyze the data, we find that, and then we kind of take it out, because that would really throw some of the algorithms off if we didn't do that. And then I'm just writing out to what we call our staging. It's a binary format. It's compressed. It's really fast for us to read and write in parallel. So I'm just dumping the data back out into HDFS at that point. All right, so now I have my orders kind of taken care of, the header data. Now I want to clean up my line items. I'm doing the same thing. I'm filtering the rows out with negative orders. So for quantity, I'm creating the unique transaction ID. I want to join it up with my header data that I just cleansed. And now I'm going to have all this. Now that way, I'm kind of denormalizing the data at this point, right? So I don't want it in normal form anymore. I want to denormalize it. I want all the header information mixed in with every line item. That really allows me to do very deep analysis without having to do a bunch of joins. So I do my join up front one time, and then I dump that data out, and then that's what I'm going to use to kind of iterate over every time I do my analysis. Yeah, denormalizing. So when I have a data model that's built where I have things like line items and I have orders, and there's some sort of key, foreign key kind of relationship between those, that would be a normal form. I'm going to denormalize it by taking that order data. I'm going to repeat it on every line item. So I'm kind of exploding the data a little bit, but what that allows me to do is to do analysis without doing joins. So that way, on every line item, I can see how many items were in that basket where this line item occurred. What was the total basket worth? Because then I might want to do things like, okay, let me do an analysis where for very high margin type baskets. Because if I segment that data out, I might see some different relationships. I might see some different data patterns than I would with the overall kind of population. Okay, so now I've got my line items kind of denormalized and cleaned up and ready to go. I want to do a little bit of analysis on it. And here I'm going to use this algorithm called FP growth. And this is where I'm doing my market basket analysis. I'm doing my association rule mining. And association rule mining is really about two things. I want to find items that sell well together very frequently. And I also want to find association rules that tell me So association rules are basically like I have item A, it drives item B, and it has some statistics about it that tells me how strong is that relationship. So one of the really famous ones in data mining is beer and diapers. Has anyone heard of that one? Right? So this is actually a true story, and this was, someone mentioned Teradata earlier. This was actually found by some Teradata engineers who were working with a pharmaceutical, like a Walgreens. It wasn't Walgreens, but it was like a Walgreens type of pharmacy, a national brand. And they took the data and they segmented it by day, they segmented it by hour of a day, and all these different ways, and they ran association rule mining on it. And when they segmented by time of day, they found this really weird relationship mainly on Fridays in the evening, or early evening, right after work. And it was beer and diapers. Well, why? Well, the only thing that they could decide was it must be like people heading home for the weekend and they have new babies and they go, I gotta pick up some diapers so I don't have to go out later. And I know I'm not going out this weekend because I have a new baby, so I'm gonna grab some beer while I'm here also, right? True story. And they never actually really did anything with the data, but that's kind of been a sort of an urban legend of data mining sense. But it really did happen. So that's the sort of things that we're looking for. And this is where, we're being a little tongue-in-cheek with the whole banana thing, because when we analyze this data, what do we find in almost every transaction? Bananas. So what sells with bananas? Everything. Or everything sells with bananas, whichever way you want to look at it. That's not really all that interesting. I mean, retailers know that. I mean, grocery store retailers know that, right? So you're not telling them anything interesting there. We have to do a deeper analysis than that to really find some interesting nuggets. And unfortunately, because this is user data and we're a vendor, I can't really go into a lot of deep detail about the things that we found. But those are the types of relationships that we're looking for. Oh, ARM is association rule mining, and so that's that analysis that you do. It's called an unsupervised learning algorithm, in that we don't know what we're looking for. We just sort of turn the algorithm loose in our data and see what it finds. And then it's looking for two things. It's looking for item sets, so these are items that sell well together, and it's also looking for those association rules on those item sets. Okay, so we run FP growth, and then which is that ARM algorithm, and then we get out our item sets, and you can see those here. So like these are two items, and we de-identify this data, so it's just numbers. So it's not really probably going to make a lot of sense, but yeah, these two items sell well together. The support tells you the percentage of actually transactions in the data that we looked at that we found this relationship, and the number of items. And we found up to like I think 7 item sets. Okay, and these are the association rules. So association rules have the antecedent. So this is a driver item or list of items, and then the consequent, which is the ones that are bought because of that. And then you get things like a confidence score, support score, and a lift score. And the lift is really interesting because the lift tells you did the antecedents. The lift is kind of a ratio of the support of the antecedent and the consequent divided by the antecedent. So how many times did these things show up in baskets with these things? Sort of divided by how many times did this show up. So it shows you the relationship of how strong is the relationship between, did this item drive this item? Or is it just kind of a correlation between the two? So the higher the lift, then the more you think item A drove item B. Probably didn't explain that well, but it's a good measure that it's more of a statistically valid measure than just support. So if you just looked at, bananas have a great support, but they probably don't have a very good lift, because they're not the driving item, right? They just kind of tag along with everything else.
Do you see other use cases with that algorithm outside of Market Basket?
So the question is, do you see other uses of that algorithm outside of Market Basket? Yeah, absolutely. So this is kind of the main way that we use it. A lot of data miners will use it just on not transactional data, but just on like multiple columns that they want to see how those are interrelated. It can also, because it does find correlations, it can be another way of doing like a PCA type of analysis where you want to find correlations. What are these items are correlated? But the difference is it gives you those rules, so you can see things like lift and confidence, and that helps you kind of judge better on which ones are more important than others. It'll find tons of rules. I mean, if you turn it loose, it'll find thousands of rules. And then it's kind of a data mining problem to mine your rules to see which ones are really important. Okay, so this is just a quick view of those association rules that were gathered, and it's support versus confidence, and then the size of the bubble is the rules with larger lift. So you can see we have a couple of super large lifts here. Maybe not as big in support. you really want to see something with a very high support with high lift, those are your really interesting rules that you want to investigate more. And, there's ways of filtering those and kind of going back and analyzing them a little deeper. So this is just kind of a quick hit look. Okay, so we've done our analysis. We've kind of done our data cleanup. We've done some analysis. And we want to do a little deeper dive, to the visualization. Okay, so one thing we can also get out of this is both the association rules and the item sets. We can actually then dump that out into more of a tabular form, because if you wanted to take that and maybe dump it into a database. And this is an example of, like, especially with association rules, where I can then take that information, I can put it into more of a tabular form, dump it into a database. It's an analysis type database, and then we can actually do deeper analysis within the database itself. Because a lot of people definitely more on the marketing type side or business type side, they want more of that SQL interface. They want it to work in Tableau. They want it to work in Yellowfin, whatever you're using, right? Those kind of BI type tools, they want that to work in. So a lot of times we'll take this analysis, we'll kind of clean it up a little bit, filter it, and then dump it back into a database so you can actually then query it. Okay, so now we want to visualize it. And this is where that Gephi tool comes into play. So what I did then is I took all those item sets, and for every time an item showed up with another item, I created an edge between those two items, right? So the more two items show up together, the bigger the edge is going to be. And so that creates this really nice graph. Okay, it's not a really nice graph. It's a really gross graph, right? It's really ugly. So we have to do a little work with it, right? To kind of figure out, we have to tease out the information we want. But we can see some pretty thick edges in there. And so there's some interesting information. We'll kind of figure that out. So we're going to filter it by, items that only have one or two edges. Maybe I don't care about at this point. So I'm going to filter those out. I'm going to color the nodes by the number of connections. So items with more connections are going to have, I think they're going to be redder or bluer. Well, we'll see when we look at it. And we're going to size the bubbles themselves by the support. So items that are in a lot of baskets are going to have bigger bubbles. So, again, we'll be able to visually kind of pick up on that pretty quickly. And then we're going to cluster it by the connections. And there's this really cool algorithm that Gephi supports where you can set, like, the gravity. And so that kind of depends on, that sort of, what's the word I'm looking for? That affects how it sort of spreads these things out. All right, so let's do that. And immediately we saw some really cool segmentations. And you probably, maybe you can't see these lines very well. And this was only two that we saw. There were plenty of them, but these were really interesting. So immediately we saw this very nice clustering with a small segment, or a small segment of bridge items. And by bridge items, I mean, what are the items that get me from here to here? And when we looked at this with the customer, they were fascinated because they said, we knew we had sort of a couple of different types of customers who came to our site and worked with us. And so we started looking at some of these items, and we started looking at some of these other items, and we looked at the bridge items, and it just opened up this really awesome conversation around that. And we wouldn't have found that just looking at the tabular data, right? Those relationships are there, they're just hard to see. So putting it into this sort of visual format just really opens up your mind and lets you kind of play around with the data and look at it. And if we go down to one of these in particular, okay, so there's bananas, right? Bananas are a bridge item. Well, that was kind of interesting. But also they're connected to a bunch of other stuff. And again, remember, I filtered out a lot of the data here. So, oh, yes. Oh, right. So the color is, okay, it looks like it's from red to probably a lighter color, like a blue or green, as far as the number of connections. So the more connections you have, it's on a color scale. And the size is the support within the item set. So support would be how many times did this item, so I have a million transactions, how many times did this item show up in those transactions? So it's basically the count of the items divided by the number of transactions, right? And so the bigger the bubble, the more times the item was bought. So we know then that those are popular items, right? And we've already filtered on some of that already. So we're kind of doing a double filtering here. But this is a really cool way to see some really interesting associations. And the nice thing about Gephi is, like, you can click on one of these, and it'll gray out all the other items that this thing's not connected to. So you can kind of bounce around, and I'm really just kind of tip of the iceberg on what you can do with these type of visualization tools, these graph visualization tools. So really interesting stuff that you can dive into. Okay, so now we've sort of analyzed the data. We've gotten some ideas about the data. So what actions can we take? All right, so yeah, okay, the whole banana thing, right? So that item is in just about every basket. So that's simple. We could just do that with a simple query. But we really want to find high frequency items, or sometimes high frequency items like that can really clutter the results. And so we'll just reanalyze by filtering out those really high support kind of items. And then other relationships will start to come up. So, if you go back to where we were here, if this is bananas, if we take it out of this visualization, what are we going to see? We actually might see some other relationships that are not being shown here because we kind of had to filter them out just to get to this point. So it's really interesting to go back and kind of re-segment the data, re-filter the data, and then go back and see what else pops up. So what could that, right away, that retailer looked at those bridge items and just had a ton of ideas that they could do with that. So they ran pretty quickly with that. We can do post-processing on those association rules. So we're looking for rules with high lift, which indicate one product is pulling another into baskets, and working with the data and being more on the engineering side of this, I get really interested in looking at these incredibly complex rules and associations, with 3 items driving 4 items. That's really interesting. What does that mean? And retailers don't care about that. They just want to see one item, or maybe 2 items that drive 1 item. That's what they really care about. So you kind of have to tone it back a bit so that they can have actionable data, because 3 items driving 4 items, that's kind of hard to figure out what the relationships really are that are going on there. So toning it back to 2 to 1 is a really good ratio. All right, other types of actions I can take on the item sets. Of course, we now discovered which items sell well together. And so, kind of product marketing has a field day with that. They do placement, they do coupons, they do ads. And then you want to kind of monitor how that worked. Did you actually get some lift out of it? You can go back and start segmenting the data. And ways that we've done that is like by customer, if you have customers. So tell me who your high margin customers are. Let's go back and segment the data and reanalyze it by that. And actually, you might see very different relationships. And those are important because those are your high margin customers. And so they tend to buy stuff that you make money off of, and you want to know that. And let's see, what else? Like for predictions, we've done things like cluster visits by the types of items that are being bought and by other, kind of other variables. And then you can kind of predict what kind of, if someone comes to a grocery store, you can look at what items they bought, and you can predict, oh, this is your weekly kind of big, I'm buying everything and filling up my pantry kind of visit, versus this is my, I just ran in because I forgot these items, or I'm baking a cake. Those sorts of things, right? You can start to identify those visits, and they'll actually give you very, very targeted coupons because they know what your next visit's going to be. So those sorts of things are happening. And of course, doing customer segmentations and customer segmentations in the sense of clustering is always very, very interesting, because then you get to see the different types of customers you have, and that really works well with loyalty programs to see if those are working or not. Okay, so just kind of wrapping up. So we talked about the age of data and kind of how data is, how important it is, how central it is to businesses. And I think the really important part there is that shift from master data to timestamp data. That's huge. We're starting to work with utilities who are doing smart meters. The amount of data is just incredible, but the amount of analysis they can do on it is amazing. And so it's kind of brought up a crisis of software, and that's kind of where data scientists came in to help kind of band-aid that as the vendors sort of caught up. Just building software that scales to meet that demand. And data science is really changing how we collect, how we discover, how we analyze, and how we use data. I really like focusing on that human side of it too, because that helps us understand what happened and kind of where we should go and where the field's going and how it's changing the industry. And there are a few people that have really led that are just really interesting to follow. And the lesson from bananas, deep analysis really is required. That's a really simple finding, but we need to go beyond that. And to go beyond that, kind of go back to that whole data science process, right? Cleaning the data, preparing it, getting it ready to use, modeling it. All that's really important, and how you do that, and having the tools to help you to do that very quickly. And another tool is Actionable Results. It requires heavy lifting. You have to have the right tools. You have to have the right people to do that type of analysis. All right. So I think we're going to open up to questions. Yes.
So what kinds of clustering algorithms did you evaluate?
So we use mainly k-means, which is probably an oldie but a goodie, so to speak. We're looking at doing other types, but mainly we use k-means now. Any other questions? I'm sorry. Yeah, they want everybody to speak into the microphone when you ask a question, so we can get it recorded.
I'm sorry. What was the name of the visualization tool?
Oh, Gephi, G-E-P-H-I. So if you go to, I think it's gephi.org, or just Google it, you'll find it. Yeah, it's a really awesome tool. It's free to download.
So just about the company, you offer both the tools for sale and then services?
We do services also, yes.
Yeah.
And sometimes, depending on the project, we may work with a partner on the services side. Like one of our big partners is Opera Solutions, which is a huge data mining, data science type company. They use our software, but we also will use them for doing services. If it's something like a really big data mining project that we're limited on bandwidth on services, so our focus is more on the software. We do offer services, but there may be times where we bring, kind of very focused partners in for that.
Where do you see the most growth?
Predictive analytics. I mean, everybody wants to, just about everybody running a company now is looking around going, everyone else is doing it, I should be doing it too. And so a lot of times they don't know what they want to do, but they want you to do it. We have a company that we work with here in town, a telecom company, and they collect a ton of data, right? So their switches are just throwing off data constantly, and they use maybe 2% of that data. I'm exaggerating a little bit, but maybe 10% of the data they use. They handed the data to us. We started working with them. We found all sorts of stuff in that data that they had no idea was going on. Because they were taking such a broad view of their network, we were able to kind of drill down very, very deeply at a very deep level of granularity and showed them a lot of stuff. So what am I trying to say? A lot of times people don't know what they don't know, and we have to kind of educate them on that also.
But don't you have to start that way? Kind of like, for example, when Boston bombing occurred, they were trying to figure out, what kind of bomb it was. They had to look in a very, very wide swath for a clue.
Right.
They didn't even know what kind of bomb it was. But once they found that first clue, then they really narrowed down to know because they knew what they were looking for.
Exactly. Yep, that's a really good point. So, you're given this big set of data. We're not domain experts in that area. So a lot of times we kind of have to find that first needle in the haystack a little bit, and then that guides you into other things that you can do with the data. So for example, we found on certain of their vendors were not performing very well within certain time frames of certain areas of the country. They had no clue about that. And so they were able to kind of wire that into their, using their, routing algorithms. They were able to kind of plug that in and reroute around that, knowing that was, a common problem, right? But we had to get there to know that was a problem first before they could even think about what the answer looked like. But in doing that, it really had some really funny side effects in that their utilization on their switches went down, which means they were being more efficient about how they routed calls, which means they can handle more calls. So it had this kind of cascading effect. Yeah. Which we had never thought of, right? I mean, we didn't walk in there going, we can drive your switch utilization down, right? We had no clue. We just had to kind of get there and discover it along with them and use the customer as our domain expert. Right? And that happens a lot.
In your telecom example there, then they must have had software to help them, to give them.
Yes, they had some in-house software that they had built, but being domain experts, they weren't really the data experts, which is, I know sounds a little orthogonal, or maybe not, doesn't really kind of make sense, but they knew their switches. They can almost do a lot of the sort of intuitive kind of routing without having to do a lot of algorithmic work on it. But they couldn't see, they couldn't predict the performance of their vendors, right? Yeah. They were doing more of a cost-based routing versus a performance-based routing. And they sort of needed to blend those two together. They knew they needed to, but they didn't really know why or how to get the information to help them. Right?
So what kind of more complicated models, and particularly the software you use for, say, something like a structural equation model, would you suggest?
For what, I'm sorry?
Structural equation, like causal modeling. How do you do causal modeling with your data?
Oh, causal modeling. Yeah.
Like structural equation modeling, for example.
So I'm not like a super deep data mining expert, but I mean the ways we have. Well, of course, you saw the association rule mining. That gives you some correlation type of information with causal, with the lift. You can always do PCA type of analysis also, and that will tell you, looking at my attributes, which ones are really having more of an effect on my model than others, and which ones kind of are correlated in the sense of they have the same effect on the model. It doesn't really give you causal, but it does give you more of the correlation. Sorry, I probably didn't help you out a whole lot there. Yeah. Oh, time. Okay, sorry. All right. Thank you, everyone. I appreciate your time.